let's use our practice of drawing shapes to learn a powerful way to think logically and write code more efficiently. As you see in the title, it's called relative position. Relative meaning something related to or depending on something else. So we can position things on the screen relative to other things, and that is pretty powerful stuff. Before we jump in, let's thank our Ko-fi supporters for enabling us to dedicate our time to making this course. And you can become a supporter yourself by clicking the link in the description. And now, let's head over to the computer and open up PICO-8. Like the last lesson, let's start by simply drawing 2 points on the screen. We'll start with the 3 variables we'll need: X, Y, and C for color. Like last time, I'll start them at 60, 60, and 8. Before we draw the first pixel, let's clear the screen. Then use our variables in pset, X, Y, C. Make sure that it works. And good, we have our red pixel near the center again. Now, instead of making more variables for the second pixel, like we did with x2, y2, I want to show you how we can use the variables of the first pixel to set the second pixel, like this. Duplicate this line, and then just add to the x and y variables right here. Let's add 20 to both. Let's run it, and we can see both pixels on the screen. We are drawing both pixels using only one set of coordinates. And because of that, it's easier to change their positions. Let's change the x to 10 and the y to 20. Run it, and look where both pixels are now. As you can see, they moved closer to the top left corner of the screen because both pixels rely on the same x and y variables. This is called relative position, where the position of the second pixel is related to and depends on the coordinates of the first pixel. And they are now locked in a relationship of 20 pixels apart. And that's a really handy thing, because now we don't need to create new x and y variables for each and every point or shape we draw. Instead, we could just control one set of coordinates, and the position of anything else we want to draw will always stay a certain distance away. And that's it. We can even make the color of the second pixel related to the first, by adding or subtracting to the color variable C. Let's try C plus 4 and run it. Now the second pixel is blue, because C is 8, 8 plus 4 is 12, and 12 is blue. By the way, the math is completed here first, before being given to pset to draw. So if we do the math by hand and write it out, that would be x plus 20 is 30, y plus 20 is 40, and as we said, c plus 4 is 12. This pset function gets these results, not all the math, and it simply draws a blue pixel at 30, 40. The great thing about doing it this way is we still have only 3 variables, and if we change the variables of the first pixel, the second pixel will automatically be adjusted to those changes too. So again, let's change the first pixel's x up to 90 this time, and the y down to 0, and even change the color to 10. Take a minute to see if you can figure out what changes we just made, not only to the first pixel, but also to the second. Predict where they will be on the screen and in what colors. Pause the video before I spoil the answer. Okay, ready? Let's walk through it before running it. X equals 90. And if this side of the screen is 0 and this side of the screen is 127, then 90 should be around here. Y equals 0, and we know that's the first pixel at the top of the screen. C equals 10. Okay, what color is 10? Yellow. So the first pixel should be yellow and around here. Now what about the second pixel? Well, it's not 30, 40, and 12 anymore, so let's redo the math. 90 plus 20 is 110, 0 plus 20 is 20, and 10 plus 4 is 14, and that's the color pink. So if our prediction is correct, we should see one yellow pixel about here, and a pink pixel 20 pixels to the right and 20 pixels down around here. Alright, let's run it and see. Awesome! We will use this relative approach to make things easier in our games. Since it uses less variables, it will also make our code more efficient and will spend less tokens. Once you get the hang of it, it will also make the logic easier to follow, and it'll be easier to make changes. For example, if I draw my paladin character's sprite and also draw his sword, which is a different sprite, then I want the character to always look like he's holding the sword. So at first I might think to make x and y variables for the player, and another set of x and y variables for the sword. But when I go to move the player around, I could forget to move the sword too, and it breaks the illusion that he is holding the sword. But with relative positioning, I can lock the sword to a place relative to the player's x and y position, and so they will be drawn correctly no matter where the player moves, and I don't have to worry about the sword's position anymore. If we strip away the beautiful sprites, then we're really just talking about 2 points on the screen, back to our 2 p-sets. So realize that when our screen looks very simple like this, these 2 pixels could easily represent a character and their weapon, or the center point of a radar and the end point of the line, or an enemy and their shield, or a health bar's starting and end points. And I could go on and on. So many things in a game can be broken down to just 2 points that are fixed together in some relationship. Let's see how we can use this to easily draw more interesting shapes. We're not going to get into animation yet, but we can at least draw one of the examples we gave, like a health bar. Just by looking at this picture, can you imagine how many shapes we used to draw it? Take a minute as a mini challenge to see if you can figure it out. Alright, now the way that I imagine this is blown out and separated into its layers. Remember that the layers are simply the draw order. So when we start drawing this, we can start with the background first and make our way to what should be drawn on top. I noticed a little shadow at the bottom, and that could be a line, or it could be a whole rectangle and we're only seeing the bottom edge. Since most of the shapes in this health bar are rectangles, I am imagining where the defining point will be for all of them. Like most things in PICO-8, rectangles are drawn starting at their top left corner, so that sounds like a good reference point to use. Now let's imagine where the same point could be for all the layers. So, it'll be easier if we draw every layer as a rectangle and all of them use this same reference point as their top left corner. Now that we have a plan, let's build it. We don't need the p-sets anymore, so let's replace them with our first rect, with its top left corner at x and y, and its bottom right corner at x plus 20 and y plus 20. The color of the shadow looks like it's color number 13. Let's see what we have so far. Well, it looks nothing like our health bar yet. First, let's move it to the middle of the screen. We have to change our reference point, the x and y variables. Since it's going to be wide and short, I should imagine the grid of screen coordinates to guess where it should be. I'd like the top left corner to be about here. So on the x-axis, that's around 30, and on the y, that's maybe 50. So let's change the values of the variables. X equals 30, y equals 50. And I don't think I'll use the color variable here since I want to make each layer exact colors and not related to each other. So we can just delete this. Run it now, and the position looks good, but now we need to make it wider and shorter. How wide the rectangle is depends on what we add to its x, and how short or tall it is depends on what we add to its y. So let's fiddle with these numbers here until we find something we like. We want it wider, so increase the x plus 20 to something like 60. And we want it shorter, so let's decrease the y plus 20 to 10. Run it? Yeah, that looks good. Okay, that's the backmost layer of the health bar. Next layer looks like it's the filled in dark blue background layer here. We could draw it as just the right side, but then we'd have to worry about locking the left side of the blue rectangle with the right side of the red rectangle, and when we animate it, then both rectangles have to move together. So to make it simpler, the way I imagine this layer is behind the entire length of the health bar. That makes it easy to set this layer one time and forget it. Alright, so we need a rect fill this time, and it has the same reference point, x and y. And you know what? Let's just use the same endpoint as well. X plus 60, y plus 10. And dark blue is number 1. Now that's going to cover up our first rectangle, so we need to adjust things so our shadow appears below the health bar. we could either increase the shadows numbers here or decrease the dark blue numbers here. And this is going to start getting real fiddly again, where I'm dealing with a lot of big numbers inside of these parentheses, and we're only on the second layer. So before it starts getting more complicated, I want to make it easier on myself again by using more variables. What do these numbers represent exactly? Well, this number adding to x controls how wide the bar is. So yeah, this 60 is the width. And the number we add to y controls how tall or short the bar is. So this 10 is the height. Sweet. So instead of adjusting the width and height by fiddling with these hard-coded numbers every time, let's simplify it by extracting these out into variables. Width is commonly abbreviated to just w, and that equals 60. Height is commonly abbreviated to h, and that equals 10. Now we can replace the numbers in the parentheses with our new variables w and h. I do want to point out that you could definitely spell out the words width and height to be your variables, especially because the W looks like a U in this font, and you might not be used to it yet. So if that's easier for you to read in your code, then by all means do that. Just make sure that you change all the W's and H's to width and height, and be careful to spell them correctly every time. The main reason I'm choosing to use single letters instead is because it takes up less space on our small PICO-8 screen here. But like I said, W and H are very common abbreviations, so you should get used to reading them as meaning width and height. Alright, now where were we? Yes, we are drawing 2 layers of the health bar, but the shadow layer is hidden. And in the code, we sort of have a second reference point to work with. X plus width and y plus height is the point of the bottom right corner. Before, we thought of drawing rectangles as 2 separate points, x1, y1, and x2, y2 like this. But now, instead of x2, y2, we are using the relative position a certain distance away from the first point, simply named x and y. So now when we think about our rectangles, we have the main reference point of x and y, and we add width to go right, and we add height to go down. So this bottom right corner's coordinates are now x plus width, y plus height. And because of this, it's now much easier to adjust the shadow to appear lower than the dark blue rectangle. This shadow rectangle starts at the top left corner and stops at the same width and height, but we actually want it to be 1 pixel taller. So now that's as simple as y plus height plus 1 more pixel. So let's do it. This is the shadows code, and we can add a comment to help us remember. Shadow and background. And so we just add 1 to the shadow's height. Run this, and now we can see the shadow. Alright, back in the code, and with the math being used in the parentheses like this, it's getting a little harder to read and keep track of what's what. So let me show you another way to space things out and think of them a little differently. We've been grouping this data by top left corner coordinates and bottom right corner coordinates. But now let's space them all out. This helps us see the math going on more clearly. And actually, we can look at these 4 pieces of data as the 4 sides of the rectangle. X and Y together define the top left point. But x by itself defines the left side. Y defines the top side. X plus width defines where the right side is drawn. And y plus height defines where the bottom side is drawn. We didn't change anything about the code or about how the rectangle functions work. All we changed is our perspective when thinking about the data. And sometimes it's easier to think of them as 2 separate points at the corners. And sometimes it's easier to think of them as sides. The way we set it up this time, using width and height variables, I think it's easier now to think of them as the different sides. So left side, top side, right side, bottom side. And the last thing we did was add 1 to the bottom side of the shadow, lowering the whole bottom side down 1 pixel. Now, changing perspectives like this can cause headaches. So if you're starting to feel one, don't worry. It just means your brain is working on it, and it just hasn't clicked yet. The solution is to see more examples. So you can pause here and experiment with it, like, if this X is really the left side, then I should be able to subtract 1 from it. And yeah, now I see the left side of the shadow. Or how about -3? Or 10? Okay, yeah, changing the X is definitely only changing the left side of the shadow's rectangle. So go ahead and do that until you feel this perspective really click in your mind, and your headache should disappear. Alright, if you're ready to move on, then I bet we can quickly add the rest of the layers using these variables, and draw the other layers all relative to each other like this. The next layer is the red bar that would be animated to show the health level. It's a filled-in rectangle. So let's write rect fill, parentheses, and for the top left corner, the same X and Y is fine. And let's just write X plus W and Y plus H for now. And color number 8 for red. Right now, our new red rectangle is covering the dark blue rectangle. So let's make things simple. Let's say we want to draw the health at 50%, half of the full health bar. So in the code, let's find the right side, which is X plus width. But we don't want the full width, we just want half. So couldn't we just divide width by 2? So now, the right side will be X plus half the width. Makes sense. Let's try it. Nice, that was easy. And looks like we have a final layer, the outline. So back in the code, let's write the outline as rect, parentheses, XY, the full width and height, so X plus W and Y plus H, and color number 6, a light gray. And there we have it, 4 layers of a cool looking health bar. The last thing I want to point out is how these relative positions can simplify the way you think about making changes or adding to this health bar. Remember how the reference point of all things drawn on the PICO-8 screen is the top left corner, where it is 0, 0, and we call that the origin, right? Well, these X and Y coordinates form the main reference point for all of these rectangles. So you can call this the health bar's origin. We call this a frame of reference. In past lessons, the screen's origin has been our only frame of reference, and all points of all shapes that we drew were based on that. But now that we set up our variables to be relative to the top left of the health bar, we can think of the health bar's origin, X and Y, as point 0, 0 with its own grid. And that makes it easier to think through where to place more things relative to this point. For example, let's add the word health above our bar. Let's imagine placing it here, and in our new frame of reference, that is -6 on the y-axis. So keep that in mind, y, -6. And now let's write print, parentheses, and it needs a string, so quotation marks, the word health, then our frame of reference, the health bar's origin of X and Y. But we want to write it at y, -6, which is just y minus 6. And let's print it in the color white, number 7. There we go. How easy was that? This is the power of relative positions that allows you to think and problem solve with different perspectives and frames of reference. And now, if I want to move the entire health bar with all of its pieces, I only need to move a single point. Let's just move it to the bottom right of the screen. Now I'm back to thinking with the screen's origin as my frame of reference, and I'm imagining dragging the health bar's reference point to a spot where I can still see the full health bar. That should be around 60x and 110y. And thanks to how we wrote all of this code based on and relative to these coordinates, we should only need to change these two variables right here. X equals 60, y equals 110. Run it, and look at that. All the layers and even the label of the health bar moved as one to the new position. I hope you are as excited to master this skill as I am for you, because the potential of it is an absolute game changer in terms of how well you prepare your code, use your variables, think through different frames of reference, and solve problems while creating your own games. For now, I have a few challenges that I want you to tackle using our health bar code here. It's okay to watch to the end of the video and see all of the challenges, then come back to tackle them one at a time. Challenge 1. Try to make the shadow look like this. Challenge 2. Now make it look like this. Challenge 3. Try moving the word health directly in front of the red health rectangle and change the text color like this. Challenge 4. Try adding a line to the end of the health like you see here. Challenge 5. Squeeze the health rectangle thinner so we can see the border at the top and bottom. When you make your own games, you'll be adjusting tiny details like this to make your game look just right. So this is great practice to be able to make those changes quickly. Lastly, to prove to yourself that you fully understand this lesson, I challenge you to draw this vertical energy bar, complete with its extra fancy decorations, using only code. There's a lot going on here, so look closely, break it down into its layers, build one layer at a time, and make sure you use relative coordinates to make it easier and lock all the separate shapes together. I suggest you write this in a new tab, and you don't have to clear the screen again. That way you can still show the health bar and refer to its code for guidance. Good luck, and have fun!